Let's define some of the basic functions that we define in trigonometry. And we're going to be talking about three functions which we call sine, cosine and tangent. These are all functions which we define of angles. They're functions of angles. Let's try to understand what they represent. So to start with, we're just going to draw a XY plot. So a two-dimensional graph with an x-axis and a y-axis. And we're going to take a line of unit length, so length 1, and we're going to rotate it in a counterclockwise direction starting from the positive x-axis, so that we define a circle, a unit circle. That is a circle with unit radius, a radius of 1 unit. So at any point that as we rotate this unit length line about in the counterclockwise direction from the positive x-axis, we have an angle which we'll call theta, and the sine of the angle is simply defined as the y distance, the vertical distance, the distance along the y-axis. So this distance here is equal to the sine of the angle theta, abbreviated to sin, but pronounced sine. That's this length here. Similarly, the distance along the x-axis is defined as the cosine, abbreviated to cos, or cos of the angle theta. So we have here the sine of theta, and we have here the cos of theta. What about this third function that we mentioned, the tangent or tan of the angle theta? Well, tangent is simply defined as the sine of the angle over the cos of the angle. So it's the y distance, the y length, over the x length. And that's the tan of the angle theta. Now, we take into account whether we're looking at the positive direction or the negative direction on the x and y axes. So for angles which are greater than 0 degrees but less than 90 degrees, that is somewhere in this quadrant here, the sine of the angle is measured in the positive direction on the x-axis, so it's a positive number. The cosine of the angle is also measured in the positive direction along the x-axis, and that's also a positive number. And the tangent of the angle, which is simply the one divided by the other, the y length over the x length, is also a positive number divided by a positive number, which is a positive number. However, if we take our angle and we continue to rotate our line and we move into the second quadrant here, so that we now have an angle theta which is greater than 90 degrees but still less than 180 degrees, then we have a y distance or a sine which is still positive, so sine of theta is still positive, but this time the cosine of the angle, which is, that was the sine, this is the cosine of the angle, but the cosine of the angle is now measured in the negative direction along the x-axis, so the cosine of the angle is actually negative. You'll find that when you put numbers into calculators, some calculators will take into account the sine, some calculators will not take into account the sine, and they'll just give you the value. So for example, if you put into a calculator and set it into degrees and ask for the sine of, say, 100 degrees, it should give you if you ask for the cosine of 100 degrees, it should give you a negative result, but some calculators won't just take into account that. Just bear in mind that whichever, whether a cosine or a sine is negative or positive actually depends on which quadrant the angle is in. So continuing looking at these then, the tangent of the angle, if it's in this quadrant here, is a positive number divided by a negative number. So tangent of angle theta in this quadrant is also negative. If we move into this third quadrant, so our angle is now this angle here, somewhere between 180 degrees and 270 degrees, then now the sine, our y component, is also negative. And the cosine of the angle, which is the x distance, is negative. And the tangent of the angle is now a negative number divided by a negative number, so a tangent of the angle in this quadrant is actually positive. And if we continue round into the fourth quadrant, so that we have an angle down here, which is greater than 270 degrees, but less than 360 degrees, we now have a sine, which is the y component, which is negative. We have a cosine, which is now in the positive direction again. So cos theta in this quadrant is positive, and tan theta is a negative divided by a positive, which is a negative again. If we consider angles which are greater than 0 but less than 90 degrees, so for example, back to our original theta here, this angle, then we can define these functions in terms of a right-angled triangle. We can create a right-angled triangle by taking our radius here and drawing a vertical line parallel to the y-axis such that it intersects the x-axis at a right angle here, and we have a right-angled triangle. So let's look at that right-angled triangle, and let's call the angle opposite the right angle, this length here, the hypotenuse, and let's call the angle which is adjacent to the angle we're interested in, theta, the adjacent side, and let's call the angle which is opposite to the angle that we're interested in, the opposite side. So in this case then, just for angles which are greater than 0 but less than 90 degrees, we can define the sine of an angle theta as being equal to the opposite side divided by the hypotenuse. And likewise, we can define the cosine or cos of the angle theta to be equal to the adjacent side over the hypotenuse. And we said that the tangent of the angle is equal to the sine divided by the cosine, which is opposite over hypotenuse divided by adjacent over hypotenuse, which becomes just the opposite over the adjacent side. Let's take a look at some related terminology. We'll very often see that we'll write, for example, the sine of an angle. Let's say, for example, the sine of 45 degrees actually equals 1 over root 2. If we want to go the opposite way and take a number and find out what that number is the sine of, then we use the terminology sine to the minus 1. So sine to the minus 1 of 1 over root 2 is 45 degrees. Now that's a bit confusing. It can be a bit confusing because usually we use the term to the minus 1 to mean 1 over. For example, if we write x to the minus 1, that equals 1 over x. But sine to the minus 1 of theta does not equal 1 over sine theta. Just bear that in mind. This means sine to the minus 1 means the inverse function. It doesn't mean 1 over the function. And you can prove that by looking at the plugging some values in. So for example, sine 1 over sine theta is, in this case, is root 2. But root 2 is not the angle whose sine is 1 over root 2. There's another term that you'll very often see used, and I think is a better term actually. Rather than saying sine to the minus 1, we can very often see the term arcsin. And that means exactly the same thing. It means the inverse function of sine. So arcsin of 1 over root 2 equals 45 degrees. Similarly, the inverse function of cos can be written as arccos. And the inverse function of tan can be written as arctan. There are some other functions that you might see defined, which are just the inverse functions of sine. So 1 over sine can actually be written as secant or sec. I don't know quite really why we need to define individual functions for 1 over it. I mean, we don't define separate functions for other stuff, but for angles we do. So 1 over sine, which would be in a right angle triangle, instead of the opposite over the hypotenuse, it would be the hypotenuse over the opposite side. And 1 over cos, you'll sometimes see referred to as cosecant or cosec. And 1 over tan, you'll see written as cotangent or cot theta.